So today we're going to be looking at the expectation and variance of a discrete random variable. So let's get rid of that. Values of discrete random variables. So if you've got a high probability, let's call it discrete random variable, will occur more frequently than a low, oops, that's meant to say low probability discrete random variable. And that's just common sense. When a number of trials are carried out, a frequency distribution of values is produced, and this distribution has a mean or an expected value. So when we're thinking of discrete random variables, we refer to x as the expectation and it's written as e of x. So this is the value that we expect to occur most frequently. So it's the mean of the discrete random variable. So let's look at some examples. Let's look at how this actually works. So suppose we have a biased spinner, and the score can be, which we're going to call x, can be 0, 1, 2 or 3. So we have our x, and we have the probability of x taking some value. So it would be 0, 1, 2 or 3. So it can either be 0.1, 0.3, 0.4 or 0.2. And we can draw a graph to show this. So we have 0.2 here, and we have 0.4 up here. And the value can either be 0, and that's got a probability of 1. It can be 1, and that's got a probability of 0.3. It can be 2, and that's got a probability of 0.4. And we have a probability of 3, and that can be 0.2, because this is a biased spinner. So it doesn't matter how many times you spin it, the probability of getting to 0 is always going to be 10%, the probability of getting to 2 is always going to be 40%, and so on. Now, the expected frequencies of the scores in 1600 trials are as follows. So we have our x, and then we have, there, so it doesn't get muddled up with that, the frequencies, expected frequencies f. So we have 0, and so the probability of 0 was 0.1, so we take our 0.1 and we times that by 1600, and that gives us 160. Our 1, probability of 1 was 0.3, times that by the number of trials, and that gives us 480. Then our 2, the probability of getting 2 was 0.4, times it by our 1600, and that gives us 640. And then our 3, was 0.2 probability times 1600. It's a terrible 6, and that is 320. So what this means is, if we hover, we spin the spinner 1600 times, we would expect, given the probability distribution, we'd expect to have a 0 160 times, we'd expect to have 1 480 times, we'd expect to have 2 640 times, and we'd expect 3 to be 320 times. Now, remember we said the mean is the same as the expectation. So the mean is the same as our expectation value, our expected value. What do we expect the spinner to fall on? And from before, we can calculate the mean by the sum of x, the value times its frequency. So the value times the frequency here, all over the frequency. So we have, for this I'll write this down here, we would have 0 times 160 plus 1 times 480 plus 2 times 640 plus 3 times 320. And that would be divided by our frequencies, our 1600 trials, and that gives us 1.7. Now, we can obtain the same value of expectation, so our same mean, if we replace the frequencies with probabilities. So let's look at this. So the mean is equal to the expectation, and if we take the sum of the value x times its probability over the sum of probabilities. So that's going to be 0 times 0.1 plus 1 times 0.3 plus 2 times 0.4 times 3 times 0.2. Now the sum of probabilities is 1, because remember, in a discrete random variable the sum of all the probabilities will be 1. And do all that, we get 1.5, which is the same. So that means the expectation of a discrete random variable EX is the sum of the values times their probabilities summed. Because we don't need to put in, we don't have to divide it by the sum of probabilities, because that is just going to be 1. So let's just look back on this one. We get our 1.5, 1.7, 1.7, and therefore this tells us that this biased spinner, the mean value, the expected value would be 1.7, although it's not going to fall on 1.7, but it would be lying somewhere between here, which makes sense, and you could round it up to being 2. Let's get rid of that again. Let us, just to note, another way of writing this formula is the sum of x times the probability of x at the given value of x, just to be a bit more complete in the way that we'd write it. So let's consider variance. If we have this mean value, and we've seen here there'd be this mean value of around 1.7, there's a spread around that mean value. So we have our variance and standard deviation of a discrete random variable give a measure of the spread of values around the mean. These measures, like the expectation, can be calculated using probabilities in place of frequencies. So let's think about our formula for variance was sum of x squared f over the sum of f minus the mean. And so we can rewrite that as, that becomes sum of x squared p over sum of p minus the expectation squared. Now we can simplify this down to even further, so the variance becomes the sum of x squared p minus the expectation squared, because this here just equals to 1. And this becomes our variance of x. So let us look at an example to calculate the variance. So we've got this table. I was going to draw the table. We've got values 0, 5, 15 and 20. And the probabilities of x are 1/12, 3/12, 5/12, 3/12. I want to find the expectation and the variance. Oh, and standard deviation. So remember, our expectation is the sum of xp. Our variance is our sum of x squared p minus our expectation squared, and the standard deviation is the square root of variance. So let's chug away at our numbers. So our expectation will be x times p, 0 times 12 plus 5 times 3 over 12 plus 15 times 5 over 12 plus 3 times 3 over 12. Now if you look here, we've got a 12th that we can take out just to make things a wee bit simpler. It's going to be times 0 times 1 plus 5 times 3 plus 15 times 5 plus 3 times 3, and that then gives us 12 times 150, which is 12.5. Now we want the variance. Which is this formula here, so we'll have 0 squared times 12 plus 5 squared times 3/12 plus 15 squared times 5/12 plus 20 squared times 3/12 minus 12.5 squared. squared. Chugging all those numbers away, we will get 43.75. And therefore the standard deviation of x will be equal to the square root of 43.75, which is 6.61 to 3 significant figures. So hope that helps.